Yeah, thanks for the invitation to come and introduce Quminex. So for those who haven't met me, my name is Baxter, and I was a member of the Metal Oceans group at the University of Ottawa for about 6 years, before branching out about this time last year to start a new company called Quminex. So Quminex is a mineral exploration technology company which aims to find the next generation of critical metal deposits using our proprietary tools and algorithms. So what was the motivation for setting up Quminex? Well, as we all know, the discovery rate for new deposits has been falling over the past few years as the demand for metals and minerals continue to rise. If we take the example of copper, one of the most important metals for society, only 80% of the 2030 demand is currently realizable. And some estimates suggest that we need to find the same amount of copper over the next 25 years than we have found in the last 3,000 years, and that's just copper. So we started to see the early stages of this strain on the resources in 2025, where there was a short supply issue caused a 45% increase in the copper prices just within 3 months. And that means that every device containing copper will become more expensive. And coupled with that, the time to go from initial discovery to extraction is on average now 16 years and growing, and about 12 of that is in exploration. So we need to start working to find quicker ways in order to discover new deposits. So Quminex is a mineral exploration technology company that is developing new workflows to help discover new deposits. And we aim to increase the mineral exploration discovery rate using this technology. Another big issue is the depletion of near-surface ore bodies. So there's a wealth of ore deposits that are hidden deeper in underexplored areas, making it almost impossible to target using traditional techniques, and even machine learning faces this problem as well. And that's because most of the training data that we use comes from near-surface deposits, and as a consequence, these models can only predict shallow ore bodies. So we aim to overcome this by focusing on different techniques such as unsupervised data-driven techniques. So at the heart of Quminex is its discovery engine, which is built and ready to be deployed now. We've built this from the ground up with a focus on data-driven approaches and particularly feature engineering that sets us apart from our competitors. Our discovery engine ingests exploration data into our database, and then we use our feature engineering and our feature selection tools to feed into our models, and then these models generate targets that are interpreted through our mineral systems lens. And these result in targets and prospectivity maps that are explainable and quantifiable. We've tested some of these models, some of our models against state-of-the-art publications, with our tests showing that our models are significantly better in finding targets and reducing false positives. So you can see on the graph on the left-hand side that our model on the right, the Quminex model, returns a score of 0.77 compared to the state-of-the-art models of 0.68. The metric used here to compare the models is AUPA, or the area under the predictive area curve, and this tracks how good the model is identifying ore deposits and not identifying false positives. And this performance advantage reduces the area needed to explore, which in turn reduces exploration costs. Our business model is a tech-driven project generator that focuses on identifying ore deposits and conducting early-stage exploration to validate mineralization. We will build a portfolio of projects which will reduce the risk and while maintaining upside potential. So first, what we do is we aggregate data, which will be stored in our in-house database. We then use our machine learning tools to predict the targets, and followed by a de-risking phase where we aim to validate the targets through geological fieldwork, sampling and drilling, and then successful individual projects will be sold. Our competitors are our major competitors are junior explorers that rely on traditional techniques to find ore deposit, as well as some AI companies. So many of the traditional explorers are prospect generators, shown here on the bottom left. We also have machine learning driven explorers such as Earth AI, Vera AI, and Cobalt Metals, and these mainly focused on classical supervised machine learning, whereas our technology aims to identify major deposits at even greater depths in areas that are underexplored using our feature engineering and feature selection tools. So in the past year, we've built our team. I went full-time in April of this year with Mark, a co-founder. So we're 3 co-founders in total. Mark Fassbender, who Mark talked about in the last presentation, Taha Rubaha and myself, and we combine the worlds of geology, machine learning, and quantum physics. Mark is the CEO. He has a PhD in geosciences, 3 years of experience as a geoscience consultant, and over 8 years of mineral exploration research. And we met as part of the Middle Oceans group. And then Taha is also a co-founder, university professor, specializing in algorithm development, and has a PhD in quantum physics. And over the past year, we've added to our team. So we have Mohammed, TJ, and Caitlin working with us now. Mohammed and TJ are working on the models, and Caitlin is working on building the tools and the database. And we also have senior advisors in technology and finance. And we're also supported by a world-class advisory board with experts in industry, business, AI, and quantum. So over the past, what have we done over the past 11 months? Well, we've validated our market through about 70 interviews with CEOs, investors, principals, showing the potential of this type of prospect generator. We signed a contract, our first contract 2 weeks ago, and are in advanced discussions to sign some more contracts for this year. And we've also been recognized as a top 10 quantum innovator by the World Economic Forum, secured over $250,000 in grants, and a $500,000 equity investment, which was in March of last year. We're going to execute in 3 phases. So the first phase is the validation phase, which is this year and moving into next year. In this phase, we will validate our technology by working with partners to provide insights to them on their properties, and in return, receive an initial revenue. The second phase is our building phase, which starts in 2028. This is where we'll deploy our validated technology ourselves, acquiring licenses and conducting early stage exploration. And then the third phase is the scaling phase, where we will continue to acquire new licenses and move into new jurisdictions. As this year is our validation phase, we're also looking to deploy our discovery engine with partners. So we aim to provide our partners with quantifiable and data-driven targets so they can test on their properties. So if you know of any company who is faced with specific exploration or data-related problems that cannot be solved with out-of-the-box approaches, feel free to chat with me at the coffee break. We are also raising a seed round of between $1.5 and $2 million at the moment, which closes in April 31st of this year. We've signed a term sheet with our lead investor last month, and to date we have reached $1 million in investor commitments, but we're still looking for a few more investors to join the round. So yeah, thanks a million for allowing me to introduce Quminex. This wouldn't have been possible. Quminex wouldn't have been possible without Metal Earth, because that's where myself and Mark Fassbender met. We had the opportunity to grow and learn over the past few years. So yeah, and if you want to know more about Quminex, I'll be outside in the hallway with a coffee in hand. So thanks very much. Thanks, Ross.